Hi, good to see you again. Welcome to Block 2, Developing Geometric Reasoning, Lesson 8. I'll share my screen. So, in your previous lesson, you learned how to solve complex angle problems using most of your learning or all your learning in developing geometric reasoning. In today's lesson, you're going to develop geometric reasoning more and you'll learn how to find and use the angle sum of any polygon. Remember to like the video. Remember to share the video with those you think can benefit. Subscribe to the channel and click on the notification bell so that when new videos are released, you will be notified. Thank you. Before we start, I would like you to pause the video and answer these retrieval practice questions in 4 minutes. Assuming you've paused the video and you've answered the retrieval practice questions, here are the answers. Let's discuss them. So a pentagon has 5 sides. A nonagon has 9 sides. Octagon, from the word octopus, has 8 sides. And a hexagon has 6 sides. Next, we were asked to work out the size of the angle labeled x. We know that the sum of the angles at a point is 360 degrees. So to get x, we'll simply subtract 53 degrees from 360 degrees. Next, question 3. What is the sum of the angles in a triangle? It is 180 degrees. And what is the sum of angles in a quadrilateral? It is 360 degrees. Let's do some new learning for this lesson. Well, we know that the sum of the angles in a triangle is 180 degrees. And we also know that the sum of the angles in a quadrilateral is 360 degrees. But if we split the quadrilateral into 2 triangles, what do you notice? Well, the sum of the angle in one of the triangle is 180 degrees, but we have 2 of them. So we have just divided the quadrilateral into 2 triangles. So we can say it is 2 lots of 180 degrees. What about if we have a 5-sided shape and we decided to split the triangle, the pentagon, into 3 triangles? Well, we can say we have 3 triangles. So the sum of the angles is related to 3 triangles. So it will be 3 times 180 degrees. I want you to pause and think. What is the relationship between the number of sides and the number of triangles that we can get? What is the relationship between the number of sides and the number of triangles that we can get? Well, I'm sure you've noticed that the number of triangles that we can get from the polygon is equal to the number of sides subtract 2. So think about this one. So here we have 4 sides. We were only able to get 2 triangles from it. How do we know? 4 sides subtract 2 is 2. And look, we have 2 triangles. Here we have 5 sides. 5 sides subtract 2 and we have 3 triangles because 5 subtract 2 is 3. Also notice how we split the shape into those number of triangles. We always start from the same vertex. Eva is working out the sum of interior angles in a 16-sided shape. Here is what Eva came up with. I want you to think, Thinking about the statement I just made about how we produce the triangles from the polygon, what mistake has Eva made? Well, we know that we learnt about this relationship just now, that the number of triangles is related to the number of sides subtract 2. So we should actually have 14 triangles. And to get the sum of the angles in the polygon, we simply multiply 180 degrees by the number of triangles we can get from the polygon. In this case, it's going to be 14 times 180 degrees. And then note that Eva did not produce the triangle from the same vertex. She started from the middle. And look, if Eva had done it correctly, this is how she would have produced the triangles from the vertex. And she would get 14 triangles. I want you to pause and practice what you've just learned. Pause the video and answer question 1 in 2 minutes. Assuming you've paused the video and you've answered question 1, here are the answers. Let's discuss them. So for question 1, you were asked, the sum of the interior angles of a triangle is 180 degrees. Split the polygons into triangles to work out the sum of their interior angles. Your lines should not overlap. The first one has been done for you, which is this here. And you can see if you were to do this, this is what you will get. So one way to quickly know this is you have 1, 2, 3, 4, 5, 6. So you have 6 sides. So you know that you're going to have to get 4 triangles from the shape, because 6 minus 2 is 4. So I repeat, to know the number of triangles that you can get from the polygon, count the sides and subtract 2 from it. Then once you get that information, you know that the sum of the angles in a triangle is 180 degrees. So the sum of all the angles would be 180 degrees minus the times the number of triangles that you produce from that shape. And these will be your answers. All right, pause the video and answer questions 2 and 3 in 4 minutes. Assuming you've paused the video and you've answered questions 2 and 3, here are the answers. Let's discuss them. So for question 2, you were asked to complete the table. So you know the number of sides. To get the number of triangles, you simply subtract 2 from the number of sides. And that's that information there. And then the next thing is the sum of the interior angles will be these numbers. So the number of triangles that you can get from here, from the shape, times 180 degrees, because the sum of angles in a triangle is 180 degrees. For question 3, you were asked, Danny is working out the sum of the interior angles of a polygon. Here are her workings. What mistake has she made? Well, she has not drawn the triangles from the same vertex. The lines should not overlap. Pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered the question, here are the answers. Let's discuss them. For question 4, you were asked to write an expression in terms of n for the number of triangles inside the shape. It's n subtract 2. So by now you should know if n is the number of sides, you can simply subtract 2 to find out the number of triangles that you can produce from the shape. And B, write an expression in terms of n for the sum of the interior angles of the polygon. Once you found the number of triangles you can get from the polygon, the next thing you do is to multiply that number by 180. So if the general expression is to subtract 2, the next stage to find the sum of the interior angles of the polygon is to multiply that by 180. Let's do some new learning. If you recall from our previous lesson, we talked about or we learnt about regular polygons. What is a regular polygon? Have a think. Well, a regular polygon is a polygon that has equal sides and all equal angles. So I repeat, a regular polygon is a polygon that has all equal sides and all equal angles. And here are examples. These are all regular polygons. You can see they have equal sides and equal angles. Here is another example. If we're asked to find x, which is the interior angle x of this dodecagon. So dodecagon has 12 sides. So if you count, you will see that we have 12 sides. How do we go about this? Well, there are different ways to solve this problem, but the one I want you to pay attention to at this stage is step 1, you find the sum of the interior angles. Step 2, you divide the sum of the interior angles by the number of sides. So if you think about it, if we find the sum of the interior angles, they are all equal, of course, it means we have just found the sum of all the 12 angles. But we do not know the sum of what we do not know the angle of one of the angles. So if we know the sum of all the 12 angles, to find the angle of one, we just divide that by 12. So that is the method we'll use. And of course, we know how to find the sum of the interior angles of any polygon. So I want you to give this a try. Pause the video and try this. Well, I'm sure you would have got this. So the sum of the interior angles will be the number of sides, subtract 2 times 180 degrees. And that will give us 1800 degrees. Now, this is the sum of 12 of the angles. So to get just one angle, we'll divide this number by 12, which will give us 150 degrees. Now, how do we find the exterior angle? Just a minute. Let's get back. Okay. The next question is, the diagram shows a regular dodecagon. How do we find the size of the exterior angle? Well, you can see that these are adjacent angles on a straight line. You can see we know the interior angle, and we can see to find that angle, we can simply subtract 150 degrees from 180 degrees, which will give us 30 degrees. So something you should know is if you know the interior angle of a regular polygon, you can find the exterior angle by subtracting that angle from 180 degrees. Let's look at this example. Here, we have been asked to find x. How do we go about this? Have a think. What do you know about the angle x and this other angle here? Well, We know that the interior angles in a pentagon sum to 540 degrees. How do we know that? We know that we have 5 sides. So to find the sum of the interior angles, we'll do 5 subtract 2, which will give us the number of triangles we can get from there. And then we'll do 3 times 180 degrees, which is 540 degrees. Now that we know the sum of the interior angles in this pentagon, we need to find out what the angle of each of these angles are. Now, to find that, we simply divide 540 by 5, which will give us 108 degrees. So each of these angle is 108 degrees. But take note that we have a square, and in that square, we have 90 degrees. Now, it means 108 degrees is made up of x and 90 degrees. So if 108 is made up of x and 90 degrees, to get x, we can simply subtract 90 degrees from 108 degrees, which will give us 18 degrees. It's now time for you to do some practice of what you've learned. Pause the video and answer question 5 in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. So for question 5, you were asked to work out the size of angle X in the regular polygons. Now you can see these hatch marks. They tell you that these are equal sides and the angles obviously would be equal, so they're regular polygons. So the number of sides is 5. So the sum of the interior angles will be 540 degrees. How do you get that? You do the number of sides minus 2, which is 3, and then you times that number by 180 degrees. So this number 3 represents the number of triangles that you can get from this shape. And you know the sum of the angle in a triangle is 180 degrees. So it means if we have this shape being made up of 3 triangles, it means all the angles in here will be 3 times 180 degrees. And you can see the calculation here. Next, you're asked to find each of the angle. So to find x, we know that all the 5 angles added up will be 540. So to find each angle, we'll do 540 degrees divided by 5, which is 108 degrees. Here, we'll do the same thing. We have 6 sides. So it means we'll have to find the sum of the angles, we'll do 6 minus 2, which is 4. And then we'll do 4 times 180 degrees, which will be 720 degrees. To get each angle, we'll do 720 degrees divided by 6, which will be 120 degrees. Okay, let's look at the other questions. Let's rub this off. All right, so for this one, we have 8 sides. So we'll do 8, subtract 2 to get the number of triangles we can get is 6. To get the sum of the interior angles, we'll do 6 times 180 degrees. And then to get each angle, what each angle will be, of which that will help us get x, we do 1080 degrees divided by the number of sides, which is 8. And that gives us 185 degrees. Here we have 10. So we do 10 minus 2 to give us the number of triangles we can get. Next, we'll do 8 times 180 degrees. That gives us the sum of the interior angles. Next, to get the angle of each, to get each interior angle, we'll do 100, the sum of the interior angles divided by the number of sides, which will give us 144 degrees. Pause the video and answer question 6 in 2 minutes. Assuming you've paused the video and you've answered question 6, here are the answers. Let's discuss them. For question 6, you were asked, the diagram shows an interior angle of a regular hexagon and its adjacent exterior angle. What is the size of the interior angle of the hexagon? So the first thing you do is you say, well, what is the sum of the interior angles? So hexagon has 6 sides, so you do 6 minus 2, which is 4. And then you do 4 times 180 degrees, which will be 720 degrees. The next stage, to find the interior angle, just one of them, you do 720 degrees divided by the number of sides, which is 6. All right. Now, if you do that, that will give you this angle to be 120 degrees. Now, you know that these two angles will make 180 degrees. So to get the exterior angle, you do 180 degrees minus 120 degrees, which should be 60 degrees. And then you were asked, give a reason for your answer. Well, angles on a straight line sum to 180 degrees. Pause the video and answer questions 7 and 8 in 4 minutes. Assuming you've paused the video and you've answered questions 7 and 8, here are the answers. Let's discuss them. For question 7, you were asked, a regular polygon has 24 sides. Work out the size of each interior angle. So stage 1, we do 24 minus 2, which is 22. So it means the sum of the interior angles. So this 22 means the number of triangles we can get from this regular polygon that has 24 sides. Now, we know that the sum of each triangle, the sum of the angles in each triangle is 180 degrees. So it means the sum of all the angles that is being held by this 24-sided shape will be 22 times 180 degrees. So 22 times 180 will be 3,960 degrees. So 3,960 degrees. Now, this 3,960 degrees represents the 24 equal angles in this 24-sided shape. So to get each angle, we'll say, well, let's divide this number. So let's start here. 3,960 degrees divided by 24. That will be 165 degrees, which is here. Now, you know that what we've learned so far is if you have the interior angle, you can find the adjacent exterior angle to the interior angle because you know both of them will add up to 180 degrees. So to get the exterior angle, we can do 180 degrees minus 165 degrees, which will give us 15 degrees. Here, you were asked, the diagram is made up of regular polygons. Work out the size of as many angles as you can. Record your answers using correct angle notation. Of course, you can use different methods and different ways to solve this problem, but these are some of the angles that you could work out. And that brings us to the end of our lesson. So well done for sticking around and for taking your learning seriously. In this lesson, you have learned how to use the knowledge of the sum of angles in any polygon to solve complex maths or angle problems. Until next time, take really good care of yourself and bye-bye.